Good morning, my dear friends. I hope you all are doing great. So, dear friends, today we'll be talking about internal energy of the system can be changed by following things. And what are those things? In previous class also I mentioned these three things which can change the internal energy of a system. So let us look into the first thing, the heat exchange between system and surroundings, how this can change the internal energy of a system. Have a look here. So my dear friends, let's talk about the first factor here, that is heat exchange between system and surroundings. So have a look, my dear friends. Let me take on one closed system here. Okay, this is a closed system. But remember, this closed system has basically the diathermic wall. So this closed system has diathermic wall. So let us suppose this wall is diathermic wall. Diathermic wall means it allows the exchange of heat between system and surroundings. So my dear friends, this diathermic wall of this closed system, okay, allows the exchange of heat between system and surroundings. Between system and surroundings. Everybody is aware about that because I have already discussed this thing. Now look here, my dear friends. Inside, let us suppose there is some gas is inside, and that is a system. Okay. So we are doing our experimental investigation on this particular gas. So the gas becomes the system. Correct? Now look here. And this entire thing which is here is the surroundings, my dear friends. Let us supply some heat from outside. When we supply some heat to this particular gaseous system, what will happen to the gaseous system? Gaseous system will absorb the heat and the temperature of the system will increase. Let us suppose, my dear friends, for this gaseous system, let's talk about the initial state of a system. Initial state of a system. And then we will talk about the final state of a system. Which system we have, my dear friends? We have the gaseous system here. I am supplying the heat. So heat is coming from the surroundings and going into the system, because system contains actually here a diathermic wall which allows the heat to pass through it. So heat is coming from surroundings into the system. So what will happen? Let us suppose TA is the initial temperature of the system. It is the initial temperature. And when we supply heat to this gaseous system, the temperature will increase. Yes? And that increase in temperature, let us suppose, that will be now a new temperature will be TB. This is the initial temperature of the system. And this is the final temperature of the system as we are supplying the heat. So system is absorbing the heat. So when system absorbs the heat, gaseous system, its temperature increases from TA to TB or from TI to TF, initial to final. Correct? So tell me, my dear friends, when we supplied the heat, okay, temperature has increased. Can I write down here, my dear friends, delta T? So my dear friends, I will write down here delta T, that is change in temperature, is equal to final. What is the final temperature? TB minus initial temperature, that is TA. So this delta T stands for change in temperature is equal to final temperature minus initial temperature. Correct? Now look here, my dear friends. This temperature of the system has changed because of the heat supplied. You have supplied the heat to the system and temperature has changed. That means this change in temperature is because of the heat. Heat is nothing but Q. And you know that heat is absorbed by the system. Means heat comes from surroundings to the system or into the system. That means system absorbs the heat. When system absorbs the heat is taken as plus Q. So plus Q means heat absorbed by the system. Correct? Now look here, when the temperature of the system changes from TA to TB, from initial to final, that means temperature of system increases by absorbing the heat. Correct? And remember, when temperature changes, the internal energy of the system will also change because the system is absorbing the heat. So its internal energy will also increase. So my dear friends, I can write down here it's equal to delta U. Delta U is nothing but change in internal energy. When system absorbs the heat, temperature of the system will increase. Due to increase in the temperature of the system, yes or no? What will happen? The internal energy of the system will also increase. So I hope you have understood, my dear friends. Now if reverse thing happens means like if the system is losing the heat into the surroundings, then the temperature of the system will decrease and the internal energy of the system will also decrease, my dear friends. Do remember that particular thing. So I will write down it in one line now, my dear friends. So you can see here when heat flows from surrounding into system, then what happens? We just have witnessed that there is a change in temperature, obviously, which is equal to TB minus TA. And we know that heat is flowing from surrounding into system. That means system is absorbing the heat, that is plus Q. This stands for heat absorbed by system from surroundings. When heat is absorbed by the system, obviously there is a change in what? Internal energy. So change in internal energy will take place. Especially internal energy will increase here, my dear friends. That means here internal energy of system increases. Reverse is also true, my dear friends. Reverse in the sense like if the heat is flowing from system into surroundings through diathermic wall. Have a look here. So let's write down the second point. When heat flows from surroundings or system, from system into surroundings, then what will happen? The temperature of the system will decrease. Yes or no? So obviously the heat is actually lost by the system. So minus Q. So I will write down heat lost by system into surroundings. Then what will happen? The change in internal energy will happen, obviously. But here internal energy of system will decrease. So remember, my dear friends, so this was all about the heat. How does heat flow from system into surroundings or from surroundings into system? In both cases, temperature can either increase for a system or it will decrease for the system. Same case will happen with the internal energy. When temperature increases, internal energy increases. When temperature decreases, internal energy decreases. Yes, I know, my dear friends. Please make note of this. So dear friends, now you have learned that heat will be plus when it's absorbed by the system and it will be minus when the heat is lost by the system, correct? So let's have a look at the second factor now. Work can be done by two ways to change the internal energy of the system. So what are the two possible ways by which we can do the work and the internal energy of the system will change by doing the work? Let's have a look. First way is the mechanical work and the second one is the electrical work. But look here, my dear friends, here I am doing 1 kilojoule of mechanical work, and here also I am doing 1 kilojoule of electrical work. So mechanical and electrical work which I am doing on the system. Which system I am taking here? Adiabatic system. That means no heat will be allowed to go from system to surroundings or from surroundings to system, because wall will be the insulator here. Same is the case here, the wall is the insulator. So we are taking here adiabatic system, which means we are doing the adiabatic work. Are you following, my dear friends? Have a look here. A mechanical work of 1 kilojoule is done by rotating paddles, churning the water. What is the meaning of this? Let's have a look. Let us take one adiabatic system here. And everybody knows that the walls of the system, this wall is nothing but it's an adiabatic wall. Adiabatic wall means insulator. No heat exchange is possible. No heat exchange between system and surroundings. Between system and surroundings. Correct, my dear friends? Now inside this particular adiabatic system, we will be talking about, let's take water inside. So this is the water inside the adiabatic system, my dear friends. And we are going to do the mechanical work. So when we do mechanical work, what we are going to do, have a look here. In mechanical work, we will be actually adjusting here in this particular system, rotating paddles will be adjusting. So my dear friends, in this particular adiabatic system, my dear friends, or we can also call it as isolated system. Correct? In this particular system, if we use the rotating paddles, let's have a look. Let us just draw it roughly here. The rotating paddles we are using here. My dear friends, you just have to take the rotating paddles and do the mechanical work. Let us suppose this is the rotating paddle with me. So I will be doing the mechanical work. This is called as churning. You can look at this process. This is called as churning. And here the paddles are there. The blades are there. You can see the blades here. Okay. So this guy is nothing but these are rotating paddles and we can call it as churner. That means the water which is present inside, you are churning the water by using the churner or by rotating the paddles. Yes or no? So what will happen? By rotating the water, by shaking the water, by disturbing the water, yes or no? The internal energy of the water will change. The temperature of water will also change. When you are actually stirring the water, yes, shaking the water, dispersing the water, yes or no, by using the churner, what will happen? My dear friends, the internal energy of the water will change and temperature will also change. And what happens here? We are doing the mechanical work on the system which is water. That means when work is done on the system by us, we are doing the work. That means the internal energy of the system will increase and temperature of the system will also increase, my dear friends. So both the things will increase. But how much of mechanical work you are doing? You are doing 1 kilojoule of mechanical work. How? By churning the water. Remember that particular point. 1 kilojoule of work you are doing here. So my dear friends, my statement will be here straightforward now. Have a look here. If I take two states here, one is the initial state of the system, then I will take the final state of the system. Final state. In initial state, my dear friends, let us suppose TA is the temperature in the initial state and TB is the temperature in the final state after churning. Before churning, TA was the temperature of the water, and after churning, TB is the temperature of the water. It has increased. In the same way, when temperature increases, obviously what will happen? Let us suppose UA is the internal energy of the water before churning, and after churning, UB is the internal energy of water. So this is initial internal energy, this is final internal energy. This is initial temperature of the water, this is final temperature of the water. And remember, you are doing 1 kilojoule of work. Which work? Mechanical work, by doing the churning of water, my dear friends. So when you know these terms, you can easily write down now here, my dear friends, what is the change in temperature if you look here? The change in temperature will be final minus initial. That is TB minus TA. And the change in internal energy will be what? Delta U will be UB minus UA. This is change in temperature and this is change in internal energy by doing 1 kilojoule of which work, man? Mechanical work. In which system? Adiabatic system. My dear friends, I hope you have understood. So temperature of the system has changed and internal energy has also changed. But I am telling that temperature is increased and internal energy will be also increased. Why? Because you are doing work on the system. Which work you are doing? Mechanical work. So work done on the system will increase the energy of the system. Remember that point. So please make note of this. After that, I will discuss about the electrical work. Please make note of this. So dear friends, now let us look at the electrical work. An electrical work of 1 kilojoule. Same amount of work I was doing there and here as well. There I was doing the mechanical work and here I am doing the electrical work of 1 kilojoule. Is done by using immersion rod in an adiabatic system. Next. This immersion rod you can also call it as heating element. Heating element. Let us take again the adiabatic system, which is also called as isolated system here. So let us take one adiabatic system here. Okay, my dear friends, inside again we have water. And I will call it as again isolated system. What happens? I will adjust one immersion rod into this. One immersion rod I will adjust here into the water. Okay, let us take this as an immersion rod here, my dear friends. So this is the immersion rod, let us suppose, and it will be connected to the battery. So this immersion rod will be connected to the battery. And this immersion rod is nothing but it is a heating element. It will provide heat to the water. So my dear friends, when I am using this immersion rod and how much of electrical work I am supposed to do, because here we know that these two wires will be connected to the battery. So we will supply the electric current, and how much of electrical work we are allowed to do? We are allowed to do only 1 kilojoule of electric work. So that means the electrical work done on the system should be 1 kilojoule here, correct? So this heating element will heat up the water. Yes? And how much of electrical work you are doing? 1 kilojoule. By using which rod? Immersion rod or heating element. This will heat up the water. This coil will heat up the water. Correct or not? So let's talk about now again initial state and final state of the system. Okay? The initial state, let us suppose the temperature of the water before doing the electrical work of 1 kilojoule was T. And the final temperature of the system, means this water, is TB after doing the work 1 kilojoule of electrical work. And the internal energy will be UA initial and final will be UV. So now tell me, my dear friends, what will be delta T, change in temperature? Final minus initial. And here it will be change in internal energy will be final minus initial. Let's call it as delta T dash and this as delta U dash. Okay, in order to make a difference. Remember, look here, my dear friends. How much of work you have done here, mechanical work, 1 kilojoule, and how much of electrical work you have done here, 1 kilojoule. So that means this delta T, change in temperature here, and the change in temperature here, delta T dash, they should be equal. Because you are doing equal amount of work, 1 kilojoule and 1 kilojoule of work. That means this change in temperature and this change in temperature should be equal. That means delta T should be equal to delta T dash. And this change in internal energy, delta U, should be equal to what? Delta U dash. Because in both cases, the work done is 1 kilojoule and 1 kilojoule, my dear friends. So when equal work is done on a particular system, okay, then understand there will be the same amount of change in internal energy as well as in the temperature of this particular system. Please make note of this. So dear friends, let's have a look here. As equal amount of work, and you know which work is that? Mechanical and electrical work is done on an adiabatic system. Okay. So my dear friends, as equal amount of work, that is 1 kilojoule of work, mechanical and electrical work is done on an adiabatic system. So delta T, okay, will be equal to delta T dash. Okay, that means the change in temperature during mechanical work will be equal to the change in temperature during electrical work. So I can write it like this: the change in temperature during mechanical work will be exactly same to the change in temperature during electrical work, because you are doing equal amount of work. You are doing how much of mechanical work? 1 kilojoule, and electrical work also 1 kilojoule, so they will be equal. In the same way, delta U for mechanical work and delta U dash for electrical work, yes, they will be also same because you are doing the equal amount of work. So the change in internal energy will be also same. So my dear friends, one statement will come now. If you are doing equal amount of work on a particular adiabatic system, yes, whether mechanical or electrical work, the change in temperature and the change in internal energy will be the same. Please make note of this. So my dear friends, we have discussed how does the heat exchange between system and surroundings will change the internal energy of the system. Second, we discussed how the work done on the system can change the internal energy of the system. Correct? And we also learned that if equal amount of work is done, mechanical or electrical work on a particular system, then the change in internal energy or change in temperature of that system will be the same. So my dear friends, have a look here. Now third point is change in internal energy due to metal exchange. So let us see here. Let's take one open system for this, because metal exchange will only happen in open system, not in closed system or the isolated system. So let us suppose we have an open system here. In this open system, let us suppose, my dear friends, we have some matter. Let's suppose we have some water here. Let us suppose this water is cold water. Which water? Cold water. Gases have a property that they dissolve in cold water. More dissolution is there, Because when temperature decreases, the dissolution of gas in water will increase. Remember that thing. So cold water can dissolve more gases. Yes or no? So temperature is less, dissolution of gas in water will be what? More. Correct? So temperature is inversely proportional to the dissolution of gas in water. If temperature decreases, the dissolution of gas in water will increase. That is inverse proportionality, my dear friends. Let us bring some gas from the atmosphere. Let us suppose carbon dioxide gas. So what is happening? This carbon dioxide gas is a matter. And it's coming from where? It's coming from surroundings. So carbon dioxide comes from surroundings, means from atmosphere. And it dissolves into the cold water, my dear friends. So what will happen to the mass of cold water? The mass of cold water, when the gas will dissolve into it. Now it is not only the cold water, it's a mixture now, mixture of cold water and carbon dioxide. So the mass of the substance will increase. So when mass of the substance increases, its internal energy will also increase, my dear friends. That means when carbon dioxide enters into cold water, yes, that means the mass of this particular mixture will later increase. Because after some time it won't be just cold water, it will be cold water plus carbon dioxide. So mass will increase, the size of the matter will increase, which means the internal energy of the system will change. I hope, my dear friends, you are understanding. One more factor is here. If I have a boiling water here with me, my dear friends, let us suppose this is the boiling water here. Boiling water. What will happen? The vapors will come out in an open system. The vapors are coming out. That means the system is losing the matter in the form of water vapors. So system is losing the matter into the surroundings. So here the system is accepting the matter from the surroundings. So the internal energy of the system will increase. And here the system is losing the matter to the surroundings. So the internal energy of the system will here decrease. So here I will write down internal energy. U stands for internal energy of the system increases as it absorbs, or if we can say as carbon dioxide from surroundings dissolve into water. So U of the system increases, that is internal energy of the system increases, okay, as carbon dioxide from surroundings dissolve into water. And here, my dear friends, U stands for here internal energy of the system decreases because water loses matter in the form of vapors to the surroundings. So here the matter is lost. So here the matter is lost. The size of the water will decrease here, and here it will increase because matter is coming inside. So this size will keep on increasing. So the internal energy of system will increase here, and here the internal energy of the system will decrease. Here the mass of the substance or the size of the substance will increase because more and more gas will dissolve, the size will increase, and internal energy will also increase. And here boiling water will lose more and more vapors to the surroundings. More and more vapors are lost, the mass will decrease, size will decrease, and then the internal energy of the system will also decrease, my dear friends. Please remember that. So dear friends, let's write down some important points here. We will discuss these points in detail later, but at least for time being, remember these important points. What is the first point here? Plus Q. Plus Q means heat absorbed by system. Minus Q, heat lost by system. If there is a work and work is negative, if work is negative, understand that work is done by the system. Means work done by the system. In physics, you may study that work done by the system is positive. But here, if you see here, the work is negative when work is done by the system. Why the work is negative? Because when the system does the work, let us suppose I am the system, I am doing some work. By doing the work, my internal energy will decrease. So I will lose my energy in doing the work. So that's why the work is taken as negative. And now, work is taken as positive when work, okay, is done on the system. Just recently you have seen that I was doing mechanical work and electrical work on the system, and that was increasing the internal energy and temperature of the system. Correct or not? That means work done on the system will increase the internal energy of the system. Correct? So the work is taken as positive here. Please remember that. So plus Q means heat absorbed by the system, minus Q heat lost by the system. W is negative when work is done by the system, because when system will do the work, its internal energy will decrease. When internal energy will decrease, obviously it's taken as negative. And when the work is done on the system, then what will happen? Internal energy of the system will increase. So work is taken as positive. Please remember these points. So dear friends, let us look at the first law of thermodynamics. According to first law of thermodynamics, energy can neither be created nor destroyed. Everybody knows about it. But you can transform the energy from one form to the other form. For example, electrical energy can be converted into light energy. Yes, in electric bulb. Or the same in heating element, the electrical energy is converted into heat. So my dear friends, one form of energy can be converted into the another form of energy, but you cannot destroy the energy or you cannot create the energy, remember that. But transformation is possible. So it also means that the total energy of the universe, the total energy of the universe, you mean to say that if we talk of universe is composed of system plus surroundings. These two things will make the universe, correct? So system plus surroundings will give us the universe. Okay? So my dear friends, the total energy of the universe, this is also the first law of thermodynamics, another statement of that. The total energy of the universe, that is system and surroundings, remains constant. What is the meaning of that? That means simple thing, energy lost by system, yes, is equal to energy gained by surroundings. That means if the system loses the energy, who will gain that? Surroundings. If surroundings will lose the energy, who will gain that? System. So energy of system plus surroundings will be overall what? Constant. So we know that. So energy lost by system is equal to energy gained by system. So obviously it is constant. That means the total energy of the universe, will remain constant, my dear friends. If I lose 1 kilojoule of energy, I am a system, then surroundings will gain how much of energy? 1 kilojoule of energy. So total energy of the universe will remain what? Constant. Yes, because universe is made up of system plus surroundings, my dear friends. So please remember this particular point. Energy lost by system is equal to energy gained by system. So the total energy of the, universe will remain constant. So total energy of universe, total energy of universe is nothing but it is constant. Loss is equal to gain, correct? So please remember this particular example. Let's come here in this example. When we are doing electrolysis of water, we have water liquid here, and we are supplying 286.2 kilojoules of energy. Which energy is that? Electrical energy. And we are doing electrolysis, that means we are breaking the water into 1 mole of hydrogen gas and half mole of O2 gas. So my dear friends, how much of electrical energy is supplied? We are supplying 286.2 kilojoules of electrical energy to break the water molecule into hydrogen gas and oxygen gas. So after breaking them, if I make the hydrogen and oxygen gas to react, look here, I am making these two gaseous substances to react. And what I am getting the water. And the same amount of energy which you have supplied here in the form of electrical energy, when you have broken the water, when you did the electrolysis of water, you broke the water, you supplied 286.2 kilojoules of energy. And you got hydrogen gas and half mole of O2 gas. But when you are making these two substances to react and you are getting water and the same amount of energy is coming out, but it's coming out in the form of heat energy. That means electrical energy supplied was 286.2 kilojoules and the heat energy produced here is also 286.2 kilojoules. That means the heat supplied is equal to the, or we can say the electrical energy supplied is equal to the heat energy produced. So we'll tell here electrical energy supplied is equal to the heat energy produced. Yes? When we say electrical energy supplied, it means simple thing that this electrical energy is used, yes, consumed. And how much of heat energy is produced in the second reaction? Equal amount. That means the total energy of the universe will always remain constant. You can convert one form of energy into another form. Electrical energy is converted into heat energy here, but both are equal. That means the total energy of the universe will be always equal. It will remain constant because the heat lost by the system will go into the surroundings and the heat lost by the surroundings will go into the system. That means overall energy of the universe will remain constant. That is the first law of thermodynamics. I hope everybody has understood here. And one more time I would like to explain you. When you are breaking the water, you are doing electrolysis, breaking any substance by passing electric current. So how much of energy you are supplying? 286.2 kilojoules. And now you are getting H2 and O2. This electrical energy remains stored in these two substances. And these two substances will react with each other to make water. And they will release this electrical energy in the form of heat energy now. So we supplied electrical energy to water and it remains stored in what? H2 and O2. Then H2 and O2 has reacted to give water and released this electrical energy in the form of heat energy, my dear friends. And both are equal here. So please remember that particular thing. The total energy of the universe will remain always constant. Please make note of this. So dear friends, let us see now the mathematical formulation of first law of thermodynamics. It's quite easy. Have a look here. Let us take on one system here. And this is the piston, okay? So what is the internal energy of this particular system? Let us suppose there is some gas inside this particular system. And the internal energy is here, U1. U is internal energy. So my dear friends, here we have internal energy. Let us suppose U1 is the internal energy of system. At which state? At initial state. This U1 is the internal energy, correct? Now I am doing this thing, look here, plus Q. I have told you already, this is the heat absorbed by the system. By the system. Plus Q means heat absorbed by the system. That means this system, let's suppose there is some gas inside, it will absorb the heat. Plus Q means heat will be absorbed by the system. So when the heat is absorbed by the system, then internal energy of the system will increase. So I will write down here as heat is absorbed by system, its internal energy increases and becomes, look here, what does the internal energy become now? U1 plus Q, and becomes U1 plus Q. That is the internal energy of the system now after absorbing the heat. Because once the system will absorb the heat, its internal energy will increase, and that internal energy after absorbing heat will become U1 plus Q. Have a look here. This is internal energy. Now finally, we are going for one more step here. That means plus W. That is work is done on the system. Work is done on the system. So when you do work on the system, obviously the internal energy of the system will again increase. So as work is done on the system, the internal energy of system further increases and becomes U1 plus Q plus W. So this is actually the internal energy at which state? Final state. So my dear friends, the internal energy at final state, how much is that? U1 plus Q plus W. U1 was the initial internal energy plus heat absorbed by the system, that will increase the internal energy. Work done on the system, that will also increase the internal energy of the system. So my dear friends, tell me now, what is the final internal energy? So look here, this is the final state, and what is the internal energy at the final state? U1 plus Q plus W. So internal energy of system at final state, and you know that the final state can be represented by UF or it can be represented by U2, because I have mentioned the initial state as U1. So obviously the final state, the internal energy at the final state can be mentioned as U2. This is UI, this will be UF. So internal energy of system at final state will be as follows. So tell me, what is the internal energy at the final state? U2, and that U2 will be equal to what? U1 plus Q plus W. Transfer this on this side. So it will become U2 minus U1. Final internal energy minus initial internal energy will become equal to Q plus W. And this final minus initial becomes delta U. That's equal to Q plus W. And this is actually the change in internal energy. Change in internal energy. And this is the mathematical derivation or formulation of first law of thermodynamics. That is, change in internal energy is equal to heat absorbed by the system and the work done on the system. Please remember that, my dear friends. And reverse is also true. That means work can be done by the system only. Yes or no, ma'am? So that means internal energy will decrease. Heat will be lost by the system. That means the heat content or internal energy of the system will decrease. So both ways it can go. But we will discuss about this further in this particular chapter. So please remember up to here, that is the mathematical formulation of the first law of thermodynamics. With this, I would like to take the leave. Have a great time. Thank you so much.